Hey there, Darksiders. We are back with one of my absolute favorite things. It's a little thing, full of details. It's a boxing video. That's right. I don't mean punching each other with our fists. I mean putting things in packages. And today, we've got some very special things and a very special package. Let's start with the box. This box was made from mostly recycled materials. This wood came from, actually, I believe it was a Craigslist find. Someone was just putting wood out. And what I did was I milled it all to the same width and cut my pieces, and I stained it dark cherry wood. I assembled it briefly with screws, some industrial hinges for the lid to open, and as you can see, this handle is a little bit oversized. In the first iteration, I did not fix this, so what I'm going to do in the next iteration of this box is actually trim this to meet both of the edges. And you're going to see a few details that I'm going to upgrade between this version and how this box will eventually be. But I'd like to start by what I've done so far. I got this mesh metal plating from Home Depot, I believe, for about, it really wasn't that expensive. I think it was about $10 for the whole sheet. And I cut it down to size with some metal snips and bent it around a piece of recycled plywood board that I had covered with some gold wrapping paper to give this layered look. Catches the light really well. Now, the items I'm keeping in this box are, let's just say, not for public consumption, so I had to install a lock just for safety, and I chose this one. I actually had this lock sitting in, I don't remember what it originally came from, but I had it sitting in my junk shop full of spare parts that I had, bits and bobs that I've found over the years, and I thought this was the perfect addition for this box. In particular, it still has its keys with it, so let's go ahead. It's locked now. We'll unlock and remove the keys. This faceplate slides over the locking mechanism. And then, like a book, the box opens. This box is empty at the moment, but we're going to get a little bit more into what goes in this box in a moment here. But let's start with the interior design. I actually put a piece of 1-inch padded foam. I cut it to fit the middle. And then beneath that, I've got some nice rubber base laid out over the bottom of that so that things, stick in place and don't move around. And I've also used that same rubber to line the interior of the lid beneath the mesh metal plating. So the item that belongs in this box, like I said, it's designed as a tool, but even though it is a non-lethal weapon, I still feel that it can be categorized, much again like a chainsaw, as a weapon. So let's talk a little bit, before I show you this item, about safety and what sort of safety protocols you should use if you ever have an item like this in your presence. Right, now that we've covered laser safety, let's get this box out of the way and show you the item that belongs in it. First, I'd like to show you the prototype upon which this item was developed. And as you can see, I've got an old piece of foam. This item used to sit in this box, and originally the box was built around this item, but this is a Mark I prototype laser pistol. I have since, as you can see, it's very delicate. I've since moved on to the Mark II, and I'll show you that a little bit later, and am about to enter the design phase for the Mark III. But I'd like to start here where it all began, just to show you a little bit about how I design things. When I come up with a concept, it starts in my mind, and I very quickly move to Blender, as you may know, to render 3D digital wireframes of the objects I'm working with. But sometimes, especially with an object that I'm going to touch and hold in my hands, I want a very specific feel for it, and that kind of work is best done, in my view, with physical materials that you can then measure and translate and learn from before you construct a digital wireframe. And in this instance, that's what I did. I designed the circuit diagram for this laser pistol just on a piece of paper with a pen, and then I went to work with some wood. Wood is one of the most fantastic materials for easily shaping, crafting to exactly the way you want it. And what I made here was a very ergonomic design that did exactly what I wanted it to do. Fit in my hand perfectly, allow me perfect access to a squeeze button trigger, and allowed me to variably place all of the component pieces for this design, so that in the Mark I prototype, I could play and test and redesign and use different component parts where needed, until I got something that was basically just a functional prototype. It's not pretty, it's not the end product, but it illustrates the wiring schematic and the design build in a Mark I prototype that can then be taken to the next level. So that's what you're looking at here. Originally, this laser pistol was designed to run off of a rechargeable battery pack that slid up into this cavity. Since then, I have actually taken that battery pack apart and recovered all the components from within it and incorporated those into the Mark II, which we'll see later on. Which we'll see here in a minute. This was actually, I believe, a 1 watt laser diode, and I've moved up in power since then, but to start, I wanted to just test it at the bare minimum level that would provide a class 4 cutting laser, as described in the instructions in the safety segment earlier, and that's what we've done for the Mark I. So when I design a prototype, especially a first version prototype, I do like to use, in addition to wood, any recycled materials that I can find. And I am proud to say that every piece in this laser pistol came from my junk pile in my shop, including the laser diode, including the original battery pack that has since been dismantled and incorporated into the Mark II, including this push-button switch, which I will give a quick shout out to. Originally came from All Electronics, one of the finest electronic shops in all of the land. If you're going to order switches or like bare bones components for anything, I would highly recommend All Electronics as opposed to a big box shop. And I will give you a link to them in the information below in case you'd like to check out what they have. They'll even send you a print catalog if that's more your style. Working with found, recycled, reclaimed components allows you to develop a functional prototype without any cost, essentially, assuming that you have everything you need on hand. It certainly minimizes costs in the design process, and if you're going to use things like zip ties, obviously this isn't a functional tool that I would take out to the field and utilize, it's just proof of concept. But to line things up, to get things in place, you can go pretty bare bones at the beginning in order to figure out how everything works, what components are absolutely necessary for the next phase of the design process, and we'll get to that next. Alright, so let's talk a little bit now about the Mark II laser pistol. As you can see, it is smaller and more compact. I wanted to use an existing design for ease in construction that had a really ergonomic grip. Also, I wanted to change out the slide-in cartridge electronics for internally built electronics, so it was important to me to have grips that were able to be assembled onto the main component piece so that I could embed all of the electronics, including the power pack, inside the device itself. This is still an amalgam of 3D printing and physical manual assembly because it's, in my view, still a prototype. It's still a work in progress. As you can see, I've used 3D printed pieces here. I've used metal pieces here and electronic components. I've also used a copper pipe as my very rough sighting mechanism, so you can see where the laser will fire. And then here in the back, I have taken apart, cannibalized that initial battery pack and used the charging circuit in order to have a charging port for this. So I can use the micro USB to charge the internal battery system, and then if I need to charge my cell phone up or something, I can actually draw power from the full-sized USB 2.0 port there from the battery pack and use it for other purposes. Also, we're going to talk about how this piece is going to fit into our box. The box was originally designed to hold the Mark I, but as you can see, the Mark I has reached essentially the end of its useful functional life. So we're going to go ahead and cannibalize these parts and reuse them for other things. And the Mark II will take its place in the box. So what we need to do is design something much like this. But instead of holding the Mark I, it will hold the Mark II. And we're going to do that out of this solid piece of foam that I've cut to size for the box. So that's going to be a little bit of process that I'll show you for this video a little bit. So a little more about laser safety. These are laser safety goggles, and you can order these online. Specific, so just see up here in the corner, inscribed on the lens itself, is the frequency, the band of the spectrum, of the light spectrum, that these will particularly protect your eyes against. So knowing what diodes and what frequencies you're emitting will allow you to purchase proper safety gear. I have done so in this case, and I'm going to show you a little bit about how these work. So in the light here, you're not going to see the beams with the strong light here on the table, but you will see the impact mark. And now let's see that again through the glasses. Right? Much easier to deal with. So these are key, and if you're going to be messing with lasers at all, you should always be wearing the appropriate safety equipment and get yourself prepared for this ASAP. Okay, so now that we've talked a bit about the upgraded item that goes into the box, let's talk about upgrading the box. I'm going to need to cut some foam to surround this new piece, so let's start with that. Items I've got here, the foam, the object itself. I like using a metallic Sharpie because it hides pretty well, it blends in, as opposed to colors. And then what I've got here is my own version of a hot cut tool. This is a X-Acto knife adapter fitting that goes into a soldering iron. And you know, I do a lot of soldering, so I actually keep a soldering station set up with a specific soldering tool for soldering. And then I have this piece that has removable heads, and I use it for variable fittings for a lot of different things. And in this case, we're going to use the X-Acto to cut this foam. But let's start by marking out where we're going to cut. Okay, and that's a pretty good pattern here. Let's go ahead and start cutting. I'm going to turn on my torch. We'll just give that a moment to heat up. Alright, this appears to be pretty hot, but I'm going to go ahead and test it with a piece of scrap before we start working on the real surface. Yep, that cuts pretty well right through. Just like butter. Cool, so we're ready to work. And there we have it. Let's give this a nice test fit. It's pretty close, and as it sits in the case will press in against the walls from all sides, so we should have a pretty snug fit. Let's take a look. Alright, here we go. Nice and snug. Alright, so there's one other modification I'd like to make to this box before I call it complete, and that is to trim off these edges where the handle overlaps on both sides of the edges of the box. That's something I just didn't have time to finish up in the first iteration of this build, and I would like to fix it now. Now, since I want to mark this while it's joined, I don't want to use a marker, because that's actually going to not only mark the piece I'm cutting, but without doubt, a little bit of marking will get onto this beautifully stained wood, and that's not what we want. So instead, I'm going to use this very thin, small flathead screwdriver, and I'm going to etch a marking line directly across where I'd like to cut the handle. Before I remove the handle, cut that line, and then we'll buff and polish it up. Probably give the handle a bit of paint before we reapply it back to this piece again. Let's go ahead and start with marking. Perfect. Okay, and I'm going to remove this handle with an old-fashioned Phillips head screwdriver. I could use a screw gun, which is what I initially set these screws with, but you know, with old pieces of reclaimed wood like this, taking a screw in and out too many times can have adverse effects with a screw gun. So I'm going to use the minimum amount of force possible, and I'm going to do this old school to make sure that we don't damage this wood as the screw comes in and out. And as you can see, I have my score line on each side, so I know exactly where to cut. So next, let's do some cutting. Alright, now we want to polish up these spiky ends and make them nice and smooth, and we'll do that on our polish. Alright, that's a lot better. So I'm going to hit this handle, I think, with some paint, and then we'll get it reattached and reinstalled. So this hinge actually started off black, but I'm going to actually make it oil rubbed bronze. I think that'll be prettier against the metal braiding of this box. Let's start by hitting those ends. Oh. Alright, so let's button this project up. Oh, that is just so much better. It's the little things in life, it's the details, and that detail has been bothering me for a very long time. Glad to have it fixed. So there you have it, a fully, beautifully boxed Mark II laser pistol built on the design of Han Solo's DL-44 iconic blaster, but in a snub-nose version. This has been Unboxing. I hope you've enjoyed it. I'll see you next time.